The Photon Era was a pivotal period in the early universe, a time when the cosmos was a seething cauldron of energy and particles. It began a mere 380,000 years after the Big Bang, a momentous event that set the stage for everything that followed. This era marked a time when light dominated the cosmos, filling the universe with a brilliant glow that would eventually shape its destiny. The universe was incredibly hot and dense, a furnace of unimaginable proportions where particles and energy were in constant turmoil. It was a seething cauldron of particles and energy, a chaotic dance that would eventually lead to the formation of the universe as we know it. During the Photon Era, photons, the particles of light, were the most abundant entities, outnumbering all other particles by a significant margin. They constantly interacted with other particles, engaging in a cosmic ballet that shaped the very fabric of space-time. These interactions were not just random collisions, they were the fundamental processes that shaped the universe's structure and behavior. The universe was opaque, like a dense fog. Light couldn't travel freely, trapped in a cosmic web of particles and energy. This era is crucial for understanding the evolution of the universe, providing insights into the processes that led to the formation of galaxies, stars, and planets. It's where we see the transition from an opaque, chaotic state to a transparent one, a pivotal moment that allowed light to travel freely across the cosmos. This transition paved the way for the formation of the structures we observe today, from the smallest stars to the largest galaxies. The Photon Era serves as a window into the universe's infancy, offering a glimpse into the conditions that prevailed in those early moments. It's a time capsule of information that cosmologists eagerly strive to decipher, unlocking the secrets of our cosmic origins and the fundamental laws that govern the universe. Imagine a universe filled with a hot, dense soup of particles. That was the Photon Era. The primary ingredients of this cosmic soup were photons, electrons, and protons. These particles were in a constant state of interaction. Photons, being massless particles of light, zipped around at incredible speeds. They continuously collided with electrons. These collisions were so frequent that light couldn't travel far. The universe was like an opaque fog. Protons, much heavier than electrons, added to the chaotic mix. They interacted with both photons and electrons. This constant interplay of particles created a dynamic and energetic environment. The universe was a turbulent sea of energy. Temperatures were incredibly high. It was a far cry from the structured cosmos we observe today. As the universe expanded, it cooled down. This cooling led to a pivotal event called recombination. This event marked a turning point in the universe's history. It occurred around 380,000 years after the Big Bang. During recombination, electrons combined with protons. They formed neutral hydrogen atoms. This process was significant. It changed the way light interacted with matter. Before recombination, photons were constantly scattered by free electrons. This scattering made the universe opaque. After recombination with fewer free electrons, photons could travel freely. The universe became transparent. This transparency marked the end of the Photon Era. It ushered in a new era, one where light could travel vast distances. This was a fundamental shift in the cosmic landscape. The transition to a transparent universe had a profound consequence. It led to the creation of the Cosmic Microwave Background, or CMB. The CMB is a faint afterglow of the Big Bang. It permeates the universe. When the universe became transparent, photons were released. These photons had been previously trapped by the hot, dense plasma. They began to travel freely through space. We can still detect these photons today. The CMB provides a snapshot of the early universe. It tells us about the conditions shortly after the Big Bang. It's a treasure trove of information for cosmologists. The discovery of the CMB was a major scientific breakthrough. It provided strong evidence for the Big Bang theory. It revolutionized our understanding of the universe's origins. Section 5. Seeds of Structure. The transition to a transparent universe had another crucial implication. It set the stage for the formation of stars and galaxies. The seeds of these structures were sown in the Photon Era. Before transparency, the universe was remarkably smooth. Matter was evenly distributed. However, tiny fluctuations in density existed. These fluctuations left their imprint on the cosmic microwave background. As the universe cooled and expanded, gravity began to amplify these density fluctuations. Regions with slightly more matter attracted more matter. Over time, these regions became denser. These denser regions eventually collapsed under their own gravity. They formed the first stars and galaxies. The universe began to transition from a homogeneous state to one with structure. Section 6. Decoding the Cosmic Message. The CMB is a goldmine of information for cosmologists. By studying its subtle temperature variations, scientists can glean insights into the early universe's conditions. It's like deciphering a cosmic message. The pattern of these variations tells us about the universe's composition. It reveals the relative amounts of dark matter, dark energy, and normal matter. It even provides clues about the universe's geometry. The CMB also provides evidence for inflation. Inflation is a theoretical period of rapid expansion in the first fraction of a second after the Big Bang. This theory helps to explain the universe's remarkable uniformity. By analyzing the CMB, cosmologists can piece together the history of the universe. It's a remarkable testament to the power of scientific inquiry. Section 7. A Cosmic Legacy. The Photon Era left an indelible mark on the universe. This period, occurring just after the Big Bang, was crucial in shaping the cosmos as we know it. Its legacy is evident in the cosmic structures we observe today. The vast networks of galaxies and clusters are a direct result of the processes that took place during this era. It shaped the distribution of galaxies, creating the intricate cosmic web that stretches across the universe. It influenced the formation of stars, determining where and how they would form within the vast expanse of space. The tiny density variations during the Photon Era acted as seeds. These minute differences in density were the starting points for the formation of all cosmic structures. These seeds grew over billions of years under the influence of gravity. Gravity pulled matter together, forming galaxies, stars, and other cosmic entities. They evolved into the vast cosmic web of galaxies and galaxy clusters we see today. This web is a testament to the dynamic and ever-changing nature of the universe. Without the Photon Era, the universe would be a very different place. The processes that occurred during this time were essential in creating the diverse and complex cosmos we inhabit. It would likely be a homogeneous and featureless expanse, devoid of the rich structures and variety we see today. The intricate structures that fill our night sky wouldn't exist. The Milky Way, Andromeda, and countless other galaxies owe their existence to the events of the Photon Era. The Photon Era's influence is a testament to the interconnectedness of cosmic events. Every event, no matter how small, plays a role in the grand tapestry of the universe. It highlights how events in the early universe continue to shape the cosmos today. The legacy of the Photon Era is a reminder of the profound impact of our universe's earliest moments. Section 8. Echoes of the Early Universe. The CMB serves as a constant reminder of the Photon Era. It's a faint echo of the universe's infancy. It allows us to peer back in time. We can study the conditions when the universe was just a few 100,000 years old. Observing the CMB requires sophisticated instruments. Scientists have developed advanced telescopes and detectors to capture its faint signal. These instruments are marvels of engineering and ingenuity. The study of the CMB is an ongoing endeavor. New generations of telescopes and detectors are being built. They promise to reveal even more about the early universe. Each new discovery brings us closer to understanding our cosmic origins. Section 9. The Dawn of Discovery. The Photon Era represents a pivotal chapter in the story of the universe. This era, occurring roughly 380,000 years after the Big Bang, was a time when photons, or particles of light, began to travel freely through space. Before this period, the universe was a hot, dense plasma where light couldn't move freely. It was a time of significant transitions and profound implications. The universe was cooling down, allowing atoms to form and light to travel unimpeded. This transition set the stage for the formation of the first galaxies and stars. It marked the end of the universe's opaque phase and the birth of transparency. This transparency allowed us to eventually observe the cosmic microwave background radiation, a relic from this era that provides a snapshot of the early universe. The study of the Photon Era is a testament to human curiosity. Scientists have used advanced telescopes and instruments to peer back in time and uncover the secrets of this formative period. It highlights our desire to understand the universe and our place within it. By studying the Photon Era, we gain insights into the fundamental processes that shape the cosmos. Through scientific inquiry, we've been able to piece together the history of the cosmos. Each discovery adds a new piece to the puzzle, helping us understand the grand narrative of the universe. We've uncovered secrets hidden for billions of years. These discoveries not only tell us about the past but also guide our understanding of the present and future universe. The Photon Era may be long gone, but its legacy lives on. The light from this era still travels through space, carrying with it the story of the universe's early days. It's etched in the fabric of space-time. The patterns and structures we observe today are direct consequences of the events that took place during the Photon Era. It's imprinted in the cosmic structures that grace our night sky. From the majestic galaxies to the intricate nebulae, all bear the marks of this ancient epoch. Each new discovery brings us closer to unraveling the mysteries of the universe. As we develop more advanced technologies, our ability to explore and understand the cosmos continues to grow. We stand on the brink of even more profound insights. The future of space exploration promises to reveal even deeper truths about the universe's origins and its ultimate fate. The journey of cosmic exploration continues. With each step forward, we come closer to understanding the vast and wondrous universe we call home.